Within Dynamo, users are able to define custom functionality using special components known as custom nodes. In this example, I'm going to define a custom node for creating mass addition functionality. Under the Dynamo File menu, go to New, Custom Node. You can now create a name for the custom node. I'm going to call this custom node Mass Addition. I can also define the category of the custom node. Within our custom node, we need to first define our inputs. Within the search bar, search for the input component. We also need to supply the name of the inputs. This first input will be called list. I'm going to copy and paste this input twice. I'm going to name the second input starting index. The third input will be called starting value. After I've defined my inputs, I can now set up the mathematical definition for the mass addition component. I'm first going to find the add component. I'm going to connect my starting index input in for the x of add. I'm now going to define a number 1, which will be added to that starting index. I'm now going to define the getFromList component. I'm going to connect my input list in for list and my starting index in for the index. I'm now going to pull out another addition component. I'm going to add the result of the getFromList to the starting value. This will serve as the basic mathematical foundation of this custom node. I now need to define one single output. Coincidentally, I'm going to name this output output. Now comes the tricky part. Dynamo is unique for most visual programming languages in that it includes a concept for recursion. In the programming world, this is the equivalent of creating a for loop, where a variable is added onto itself for a number of iterations. In the simplest terms, this means I am able to place a custom node inside of itself. In the search bar, I can now search for the mass addition component and place it inside of the mass addition component. We can connect our original list input into the list input and the results of our additions into the starting index and starting value. If we were to leave it this way, the custom node would calculate itself infinitely, so we need to create an if statement to tell the custom node to stop computing. I'm going to connect the output of our mass addition component in for the true of the if statement. I'm going to connect the starting value in for false. We now need to establish a test for this if statement. We need to have Dynamo ask if the starting index for the mass addition component is less than the list length. If this condition is met, the mass addition component will stop calculating. We need to find both the list length component as well as the less than component. The list input will go into the list length component. The result of the length will go in for the y of less than. The starting index will go in for the x of less than. If this condition returns true, the mass addition component will stop calculating. After we've defined our custom node, we can save it and then return to our home definition. Custom nodes are saved as DYF files in the installation directory for Dynamo. After our custom node has been created, we can now place it inside of our home definition. Within the search bar, we can search for mass addition. For the list input, we're going to input our number sequence. We now need to specify the start index and starting value. In this case, we're going to use a starting index of 0 and a starting value of 0. I'm now going to grab a watch node so I can see the output of the mass addition. After the watch node has been connected, we can run our definition and see that we have created a new mass addition component.